Welcome to the Inspection and Quality Assurance module for cold asphalt recycling for the plant technician. My name is Trenton Clark and I'm with the Virginia Asphalt Association. What do we hope to get through in this module? First, we just want to make sure that you understand how communication works. Being that this is more plant focused, there's two challenges within this. There's your cold in place recycling, which is done out on the site, so you need to really understand from beginning to end how contract documents play into this. But if you're at the plant, because you're doing cold plant recycling, you have to make sure that not only are you meeting the specs for the material, but if there's any specific special provisions or special provision copied notes that apply to your contract. So let's step back for a second and look at project communication. It's all very vital. And these are the different types of documents that'll be part of a project. So even if you're just supplying material to a project for VDOT, all these documents exist. We have plans all the way down to special provision copy notes. But to help you understand them a little bit more, and if you remember back to Module 1, we showed this type of diagram. So we have standard drawings on one end and special provision copied notes at the other end. So if you're out on a cold in place recycling job, you may not have some standard drawings, but you probably have some plans, unless it's a no plan job. You have standard specifications because you have to know maybe what type of paver to bring out there, what type of roller that shows up, any supplemental specifications. What they do is they update the standard specs, because these standard specs could have been written 4, 5, 6 years ago, and recently we've updated them, we've amended them, maybe we've deleted some language. We have plans, so our plans may tell us how we're building the project. We have special provisions, so for cold in place recycling as well as cold plant recycling, we have special provisions that really talk about how we do the process. How do we design the materials? What are the material qualities? And it's all laid out because it's not contained in your standard specs. And then we have some special provision copied notes. So maybe unique to a certain project or a certain district that may rewrite a little bit of that special provision. The thing to keep in mind is the copied notes are the highest level and they override everything below it. Special provisions override everything but copied notes, and so forth and so on. So you just need to keep in mind, when you look at a contract, if you have a standard specification, is there a supplemental? Is there a special provision? Or if there's plans, are there some notes in there in those plans that override? So you have to look at the overall contract document, all that part of it, to understand what you're doing. Very important in cold in place recycling. While it's just as important in cold plant recycling, doing CCPR, you're dealing more in the special provision copied notes and special provisions realm for the materials itself. If you're out in the field, many other things come into play. On projects, when we talk about communications, cold in place recycling job, and even some of our cold plant recycling jobs, we're doing pre-construction conferences. So we're getting together before the project starts, sitting down with the VDOT personnel, maybe the consultant personnel, the contractors, some of the subcontractors may be there, and we're going to talk about how the project, do we have all the paperwork, do we have the necessary sign-offs, what's the job mix? A lot of things go into that pre-construction conference. Talk about safety and things of that nature. We'll hold formal meetings. They may be required by contract, but a lot of times we'll do informal meetings and information sharing. You know, what type of results did you get? What are you doing here? A lot of communication constantly to make sure that project's successful. Very importantly, those written communication. So if something's decided or guidance is given or a request for information is made, we have written communication to document what was decided, so as we go forward, if something was to come up, we have something to fall back on and say, well, this is what was decided. Here was who was in the meeting. here's who agreed to it, etc. So let's talk specifically about the plant side of it. What does this plant technician do for these cold recycled materials? Well, it depends on who you work for. So if you're at the plant and you work for VDOT or a consultant working for VDOT, there's lots of things that you could be doing. You may be observing the collection of mix. So you're at the cold recycling plant and you're observing the technician for the contractor grabbing mix samples. You may be doing lab testing or overseeing lab testing for verification and independent assurance testing purposes. The oldie but the goodie, if you work for the department, is other duties assigned in your employee work profile. Maybe things that change over time as we continue to do this, and maybe there's some new duties that you're doing with these cold recycled materials. If you're the consultant and you're working for VDOT as a consultant, you're probably doing the same duties VDOT's doing. But if you're the contractor and a consultant's working for you, then you're probably doing all the lab testing and that part of the QC and acceptance for the contractor. Again, it depends on the setup for each company. So what does the contractor do? By spec, they're designing the CCPR, they're designing the cold in place recycled material, and they're putting it together and submitting it in a job mix formula. What's different with cold recycling than traditional hot mix asphalt, conventional asphalt mixes is there is not a specification requirement for a certified mix designer. Currently, only certified mix designers are necessary for asphalt mixes, but for cold plant recycle and cold in place recycling, there is no specific requirement per VDOT spec. What else does the contractor do? They do the quality control testing per the submitted and approved QC plan submitted to VDOT. So the contractor lays out, these are the things that we are going to do in terms of quality control. They develop it, they submit it, they give it to VDOT for approval, and if VDOT approves it or asks for adjustments, then once it's adopted, they follow those processes through. They perform the acceptance testing per the special provision for cold central plant recycling material. So as we go into that special provision, the contractor's doing those acceptance tests to make sure that CCPRM meets spec.
So what's in the CCPR job mix formula? Well, first, like other materials, the actual design is done by the contractor, or in some instances, it can be done by a third-party testing lab or a consulting lab. What's a little bit different with CCPR than something like asphalt materials is at the moment there is not a CCPR credential for mix design. So as such, it is completely the responsibility of the contractor to have a qualified individual putting together the mix design to meet the requirements that are in the specification. And as we look in Section 3 of the special provision, we see what are the details of that job mix formula. In Table 3, it outlines the gradation ranges that the material must meet. These gradations can be achieved through a combination of different millings that are being processed into various sizes. It can also include virgin materials that may be added to the process millings to hit a design gradation bands. Along with the gradations, the mix designer through the contractor is also declaring through their testing what is their maximum dry density at optimum moisture content. And that's needed to know what type of strength the material has and what type of strengths and densities to be shooting for when they're out in the field. We're providing in this mix design the percentage of stabilizing agents. So with CCPR, we're either stabilizing with a foamed asphalt or with an asphalt emulsion. Depending on which stabilizing agent is used by the contractor, unless specified in the contract, the designer must put on their job mix formula how much they're using. So many times this could range anywhere from 2 to 3.5%, depending on what is selected. You also have to know what's the percentage of weight of water that needs to be in this mix. And the reason that's important is because, again, we're trying to find out hit a maximum dry density at optimum moisture content. So you need to know what is that optimum moisture content to be able to add enough water or to monitor the moisture content in the mix as it's going to production to achieve that value, to achieve that optimum moisture content. And in tables 4A and 4B in the special provision, you can actually see the mix design criteria, whether using an emulsion or foamed asphalt. So again, the contractor or a third party that they may have contracted with provides this job mix formula and provides this information to the department for review and approval of the job mix formula.
So once we know what the job mix is, what's the plant technician doing? Well, they're doing QC and acceptance to make sure it met spec. So they're checking gradations. The job mix formula came in, it said here's the gradations. They're checking gradations, whether it's at the plant or out in the field. They're checking the stabilizing agent content. So is the plant adding the right percentage of stabilizing agent? Or is the cold in place recycler out in the field adding the right stabilization content? We're checking moistures. Moisture is very important for these to be successful during production, because with the right moisture content, it aids in the compaction out in the field to get density. We're looking at Marshall stability numbers if we're doing emulsions. So that is one of the testing requirements and acceptances in the lab is Marshall stability. How strong is it? If it's foamed, we're looking at the dry indirect tensile strength. So since it's two different types of stabilizing agents, it's two different types of tests that have different criteria. And we'll touch on those in just a moment. And we're looking at, with foamed, what's the half-life? What's the expansion ratio? So foamed asphalt is taking a neat binder, so it's an asphalt binder that hasn't been modified with polymers or other things. It's mixed with a little bit of water, and when 300-degree asphalt and water are combined, it causes bubbling, steam, it increases in volume, and then it starts to collapse upon itself as it cools. So we're looking at what's the half-life from expansion all the way down, and really how much volume did we increase. So these are things that we're checking routinely during production to make sure everything is proper. And then we're checking AC content. So is that final product with the wrap and with the different stabilizing agents, do we have the asphalt content that we were expecting? So with the CCPRM, we're checking gradations. Similar to traditional asphalt, where we're doing one test every 500 tons of material, 8 tests for a 4,000 ton lot. This is on the pre-stabilized wash material. So we've pulled a sample and we've identified that location in the QC plan where we're grabbing it at. So we've getting pre-stabilized, so we haven't added emulsion, we haven't added cement, we haven't added anything else. We've washed it, we followed AASHTO T27, and then we're checking the process tolerances and adding any adjustment points from Table 5 from Section 21109. So we're checking the gradations through the process and really to make sure is that material before it goes through, do we have the same material that we did all of our mix designs off of. When we look at the stabilizing agents, we record at the time of each gradation. So when we pull a sample, also when we're out there, we're recording what's going in. It's computer controlled, so it's either at the plant or on the CIR machine itself that we're looking at readout and saying, what are we adding? Are we adding at 2.9%, 3.1%, 2.4%, whatever it may be to match up with the mix design, but it's got to be within 0.2% of the approved job mix. And if it's not, we've got to take corrective action. So not only are we checking gradation at the plant and at the field with cold in place, we're checking the stabilizing agent that we're adding. And we're doing a daily summary report that has to be turned over to VDOT. So every time at the plant we're pulling a gradation, or if we're pulling a gradation in the field, we're making sure what is the stabilizing agent so it all works together. We want to check the moisture content because that is important. We report it when we report the AC content, when we measure it. AC content and moisture content is performed on every 1,000 tons of mix. So we pull a gradation every 500 at the plant, or we pull a gradation at locations in the field for CIR. When we do at the plant every 1,000 tons, we're checking the AC content, but we're also checking the moisture content to make sure that material's within what the job mix calls for. And here's just the simple formula. We have the original mass, how many grams of material. We dry it. We have the final mass or final grams of material, and then that difference is divided by the final mass to come up with the moisture percentage. And that moisture percent, again, is very vital, so when it goes out to the field to be compacted, that it is correct. So we're drying it to a constant weight in an oven. We're doing that oven temperature at 225 degrees Fahrenheit. We don't want to cook out the asphalt with higher temperatures. We just want nice, calm, and have it dry off. No more than 0.2% waste loss in a 2-hour period. So that's how we know when it's stable. So example, a 5,000 gram sample does not lose more than a gram. So once we're at that point, we know we've reached stable final mass that we can do our computations to check what our moisture content is. Marshall stability, we're only using it for emulsified asphalt as a stabilizing agent. We haven't done very much in the state. More to the west, Iowa, Nevada, other states have done more emulsified asphalt as a stabilizing agent. But the test is performed once every 1,000 tons or one per day when we're doing less than 1,000 tons of production. So it's similar to volumetric testing when you're doing a conventional asphalt mix. We pull it off, we do our test. It can be sampled and performed in conjunction with the gradation and stabilizing agent sampling and reporting. So it's randomly selected between 1 ton and 1,000 tons. We grab a sample. Between 1,000 and 2,000, we grab a sample. And that can be combined with our gradation checks. And we're looking, again, that the less than minimum values in Table 4, we're going to remove and replace. So as I show you Table 4 in just a moment, if it gets too weak, we remove and replace. If we're doing emulsified asphalt, Marshall stability is one of the tests we look at to confirm the properties of the material. So if we're doing a 6-inch specimen, it needs to be 2,945 pounds or greater to get 100% pay. If you're less than 2,500 pounds, you're in remove and replace. So as you're going through production, whether you're at the plant or out in the field doing cold in place recycling, and you're using an emulsion, you need to be 2,945 or greater for 6-inch or 1,475 pounds for a 4-inch for 100% pay. Now let's turn it around a little bit. So if we're using foamed asphalt instead of emulsified, and that's our stabilizing agent, again, we're doing a test every 1,000 tons. So it's no different than what we're doing if it's an emulsified. We're doing at least 1 test per day. If it's less than 1,000, we can do it at the same time we're doing our gradation and our stabilization checks. And again, we've got minimum values that it needs to meet, or we get into a remove and replace at no cost for the department. And that is in this table. So if we're at 53 PSI or greater, that's 100% pay. So if we're using foamed asphalt and we've compacted that sample and we've tested, as long as we're at 53 PSI or greater, we're good to go. But if we're less than 45 PSI, we're in a remove and replace situation. And if you're between 45 and 52 PSI, you're at 95% pay. So as you see, it's a pretty dramatic thing to go from 95% pay at 44 PSI to remove and replace at 44. So during that mix design process, whether it's an emulsion or a foam, you want to be above that minimum for 100% pay to give yourself some leeway, some coverage in case something goes on, you're still above the minimum. We talk about half-life and expansion. Again, it's only deals with foamed asphalt. So we test each load of asphalt binder. We go back, we look at table 4. 10 times when the aggregate temperature is 50 to 77 degrees. So we measure the temperature of the aggregate, what type of expansion. 8 times if it's above 77. Again, it's just some tests you perform, and your half-life, so when your volume changes by 50%, 6-second minimum, to give you enough time in that pug mill to get it all mixed. Your testing and reporting only on AC content, used with both emulsion and foam. So either way, you're still reporting on this. Using VTM 102, which is the ignition oven method, to get your asphalt content, just like with traditional asphalt mixes, you put it in there, you weigh it, and then you go ahead. Thing is, you're making sure you've already done the moisture test because you've dried it to a constant mass. You got your moisture, now you stick it in the ignition oven, and you get your final AC content. We have a wrap correction factor. So we're checking to say we know that wrap has some fines in it that'll be reported as asphalt content, so we apply a wrap correction factor to get it back to closer to the actual asphalt content in that wrap. Moisture content performed on material. We're doing both of these every 1,000 tons. We're doing it when we're doing all the rest of our sampling. AC content is reported, but it's not a price adjustment. So keep that in mind. Gradation is, AC content is not. Some other things, plant requirements for the coal plant recycle. You got to be able to deliver additives within 0.2%, so it's very, not restrictive, but very precise because we want to make sure we make the material that was designed. Got to be able to add that 5% water, again for stabilization, because that wrap that's coming in, and maybe that wrap in virgin aggregate's got moisture content, you need to know what it is so you can set the plant to add the proper amount to hit your optimum moisture content. You got to be able to maintain that liquid binder at 300 degrees. So if you're going through a plant and you're foaming it, you need to have that binder for 300 degrees. For emulsion, it's less. And you need to be able to print out stabilizing tickets and the amount of water used, again, for reporting with this plant. Last but not least, let's talk about the quality assurance program. It's laid out in the Code of Federal Regulations. Basically, it says if you use the contractor's test results for acceptance and payment purposes, the owner agency's got to have some process in place to make sure that what they're paying for is correct. So the contractor is responsible for quality control and acceptance testing of the CCPRM and even with the CIR mixes. So contractors doing all the testing, the department or their rep needs to come back behind them and make sure that accurate numbers. The main components of a quality assurance program is quality control, the things that the contractor does during the production to ensure everything is going properly. The right amount of gradation is proper, moisture content, stabilizing, whatever it may be, to monitor processes and procedures as these materials are being made. We have acceptance testing. Again, this is being done by the contractor in CCPRM and with CIR, but the owner can do it as well, so VDOT can perform it as well. In years gone past, VDOT had people in asphalt labs doing that testing. Today, now they're observing and doing independent testing behind to make sure that the results are accurate. And that's independent assurance. What is that? That's just making sure whoever's doing the acceptance testing is doing it right. So the owner, VDOT or their rep, is making sure that all the people, processes, procedure, and equipment is working. One of the checks is, are they certified? Have they gone through this class and passed the exam? If the answer to that is yes, then at least that people part can be checked off. Are all the processes, is all the equipment correct? A lot of this just goes into independent insurance. It's just another way, another set of eyes. Verification, sampling, and testing is when the VDOT can grab another sample independently, not part of the acceptance, and say, what type of answer do I get? So I grabbed a sample at 348 tons. VDOT might grab one at 712 tons. What results do they get? Do they get passing or failing results? So that's what that verification is, completely independent of the acceptance process, but you're comparing it back to the spec. Does it pass or does it fail?
So the contractor also has to provide a quality control plan per special provision. This quality control plan must be submitted at least 30 days prior to the beginning of operations. The reason for 30 days is to give the department ample time to review the different components outlined in the contractor's plan. So what does need to be included in this plan? Well, in the special provision, there are some minimum requirements. First and foremost, what's the overall quality control organization? Who reports to whom? What is their decision-making responsibility? How are they playing a role in ensuring that the product that is being delivered meets specification? We also have a list of those people that have been certified. So who's gone through the process, who's gone through the VDOT materials certification schools and has received the credential for either the cold asphalt recycling at the plant or at the field. What's the QC sampling, testing, and analysis plan? How often, other than the minimum requirements by specification to monitor, how often are you as a contractor going to pull additional samples? How are you going to be testing them? How often? And then what type of analysis may you be performing to ensure that you're providing an adequate and acceptable material per specification? What lab are you going to use? Where's the lab located? Has the lab been certified? Has the equipment that's being used in the lab been certified? So again, you need to identify that location and where that would be at. And what would happen if something goes wrong? What happens if the material doesn't meet spec? What happens if a freak rainstorm shows up? You need to have a contingency plan in place for various scenarios to how you would be handling it. And then last but not least, you can have more in your quality control plan. These are just the minimums in the special provision that a contractor must submit prior to starting operations for review by the department.
Some of the contingency plan components could be inclement weather. What happens if it rains? What are you going to do? Or your equipment break down? You know, if your paver breaks down, are you going to bring out a different paver? If your plant has issues, what are you going to do? What happens if you have material shortages? Maybe you run out of the gradation or wrap, or maybe you need number 10s to add to it. How are you going to address that? What if you don't get the density of the CCPRM that's in the field? Are you removing and replacing? What things do you take into account? So these are just some of the things that can be components of that contingency plan that is provided over to the department to consider. The independent assurance program, this is growing. This hasn't been completely documented for the fact that as this technology and these processes evolve, so does the IA. So again, we're checking the people that are doing the acceptance testing, but things that can be done is checking gradations. You know, what type of gradation? When we do a split sample, do we get the similar type of results? Grab samples and do Marshall stability or tensile strengths. Do we get similar results? And with verification, a completely separate set of tests where we can go back and say, all right, does everything line up? If we did independent verification, sampling, and testing in a section, in a ton of material, Do we get passing or failing? So it's actually a check. Does the material meet spec or not? So it's independent verification of what the contractor's done. We, again, have not documented that, but that'll be in process as these technologies grow in use. So summary, know the contract, know the contract, know the contract. Know what's in there, what special provisions, specifications. Know the CCPRM acceptance testing process. What does it look like? How do you test it? You're not doing the job mix formula, but you're testing against the job mix formula. And you're required to give all testing data either through R18 or VDOT approved forms. So with that, that's the inspection and the quality assurance program for coal plant recycled. So we're at the plant, what are we looking at? If you have any questions or comments, please direct them to your facilitator or moderator. Thank you and good luck.